Hello. So this is lesson 8.2, and we are talking about arithmetic sequences. So first, we're going to define an arithmetic sequence, of course. So an arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. So the difference between consecutive terms is called the common difference of the sequence. So let's look at writing the terms of an arithmetic sequence. We are writing the first six terms of the arithmetic sequence in which the first term is 100 and the general term is a sub n minus 1 minus 30. So our second term, so this is a recursion. So second term is going to be a 2 minus 1 minus 30. Well, that means that that's the previous. So for the first term, minus 30. And we know that our first term is 100. So it's going to be 100 minus 30, which is a 70. Okay, our third term is going to be, again, it's one less than what we're doing. So one less from 3 is 2. Minus 30. Our second term is 70. So it's going to be 70 minus 30, which is 40. Our fourth term is going to be, again, one less than we just had. So third term minus 30. Well, our third term is 40 minus 30 equals 10. Our fifth term is going to be the fourth term minus 30. Fourth term is 10 minus 30, which is negative 20. And then our sixth term is going to be the fifth term minus 30. So negative 20 minus 30, which is negative 50. So the first six terms are 100, 70, 40, 10, negative 20, and negative 50. And make sure that you're writing them in the correct order. So the first term first. Okay, then we're going to look at the general term of an arithmetic sequence. So the nth term, or the general term, of an arithmetic sequence with first term A1 and common difference D looks like this. Well, so first term, and then we've got the common difference D. Okay, so we're going to use the formula for the general term of an arithmetic sequence. For the ninth term of the arithmetic sequence, whose first term is 6, so we know, so we're looking for the ninth term. So our n is 9. Our first term is 6, and our common difference is negative 5 right here. Okay, so we're going to take the formula. Nth term is the first term plus n minus 1 times the common difference. So we're looking for the ninth term. Why do I keep writing it like a key? So no, we're looking for the ninth term. Our first term is 6. N is going to be 9. So 9 minus 1 times the common difference, which is negative 5. Okay, so 6 plus 8 times negative 5. So 6 minus 40, which is negative 34. That is our ninth term for this sequence. Okay, let's look at an example using an arithmetic sequence to model changes in the US population. So the data in the graph show that in 2010, 16% of the US population was Latino. On average, this is projected to increase to approximately 0.35% per year. Now we're going to write a formula for the nth term of the arithmetic sequence that describes the percentage of the US population that will be Latino in years after 2009. Okay, so our general formula again is the first term plus n minus 1 times d. Our n here, it's saying n years, that's going to be n. Our first term is going to be the 16%, and our common difference is going to be 0.35% because that was given. So it is increasing, so that is our common difference, and it is positive because it's increasing. So our nth term, our first term is 16 plus n minus 1 times 0.35. Now we need to distribute the 0.35, so we get 0.35 n minus 0.35. Combine like terms. So 16 minus 0.35 is 15.65 plus 0.35 n. That is our general term for this. Now, next question is, what percentage of the US population is projected to be Latino in 2030? So our n is going to be 2030 minus 2009 because that is in years after. So that would be 21. So we're looking for the 21st term. So 15.65 plus, so we're using this that we just calculated, 0.35 times 21, and that gives us 23. So our answer would be 23% of the population is projected to be Latino in 2030. Okay, next we're going to look at the sum of the first n terms of an arithmetic sequence. So the sum Sn of the first n terms of an arithmetic sequence is given by this formula here. A1 is the first term and An is the nth term. So we're going to go ahead and use that formula here. So find the sum of the first 15 terms of the arithmetic sequence 3, 6, 9, 12. First 15 terms, 3, 6, 9, 12. Now, our arithmetic sequence is S sub n equals n divided by 2, A1 plus AN. N here is going to be 15 because we're looking for the first 15 terms. That's our n. So 15 over 2. Our first term is going to be 3. Now we need to figure out what is our nth term. So for our nth term, we are going to need the formula that was given to us right here. A sub n equals A1 plus n minus 1 times d. So we're looking for the 15th term, which are the first term, again, is 3. Then we're adding n is 15 minus 1, and now we need the d. We need to figure out what our d is from here. Well, if we take and do 6 minus 3, we get a 3. 9 minus 6 is 3 again. 12 minus 9 is 3. So that has to be our common difference because the difference between all the terms is 3. So our D is 3, so we're going to put 3 here. Okay, so we're calculating the 15th term, which is 3 plus 14 times 3, which gives us 45. So now we can plug this 45 in here where it's asking for that 15th term, right here. Okay, so 15 over 2, 45 plus 3 is 48. We can actually divide by 2 and we get 24. 24 times 15 is 360. So the, the sum of the first 15 terms is 360. Again, we needed two different things here when we did the calculation. We needed the sum and we needed, or the formula for the sum, and then we needed the formula for the nth term, which was the a sub n equals the first term plus n minus 1 times the common difference. So this was what we used right here. And when we calculated the 15th term, we could plug that back into the sum and get our sum. Okay, that's it for this lesson. Let me know if you have any questions. Bye.